ourselves what exponential growth looks like by doing a little experiment. So if we can bring one of the handheld cameras in, we can have a look at this. So in this box, I have 225 armed mouse traps. And on each mouse trap, we have a ping pong ball. Now in a moment, we're going to take one more ping pong ball and we're going to drop it in through this hole in the top. And it's going to set off a chain reaction. And in this chain reaction, the number of ping pong balls flying through the air is going to grow exponentially. Okay, so who would like to volunteer to come and set this off? My goodness. Let's have you there. Yep. Guess you'd like to make your way along the end of the road. If you'd like to come and stand just there, just turn that way. Okay, that's good. What's your name?
Matthew.
Matthew, you'd like to hold that. Now, in a moment, we're going to give you a 3, 2, 1 countdown. Okay. When we get to go, all I want you to do is to place the ball in through that little hole at the top. You manage that? Yeah. Yep. Okay. Are we ready? 3, 2, 1, go! Amazing. Excellent. Okay, thank you very much. Okay, so we have a high-speed camera that was looking at that, and perhaps we can just do a little action replay and see that in slow motion. So there's the first ball, setting off a couple more. Each of those is setting off several more. And on that curve, we can see the number of balls growing in this very dramatic way. And what's really impressive about exponential growth is that the rate of growth is itself growing exponentially.
Alright guys, so I thought that was a neat little video. We're going to eventually get to exponential growth, which is a really neat subject to talk about. I have tons of cool videos, tons of cool things to talk about. I even have some fun products for us. But we're going to start out with properties of exponents, okay? And you know, with properties of exponents, this is going to help us kind of dive deeper into the material that we need to get to. But at the end of this lesson, you should be able to use properties of exponents to evaluate and simplify expressions involving powers and use scientific notation to solve real-life problems. We'll talk about that a little bit later as well. So here it says solve x times x times x times y times x times blah, 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 which equals x to the 8th y to the 6th y. How much of a pain is it to write it out like this? I mean, it really is. I mean, if I asked you to write out x to the 20th times y to the 31st, you don't want to write out 20 x's and 31 y's, okay? So we need a shorthand way to do this. So that's why we have exponents. It allows you to rewrite it so that you can condense it down and it makes it easier to work with. So right down here it says write each product as a single power of 2. Now I'm only going to show you this for the first one. Let me see if I can zoom just a little bit here. Okay. 2 to the 5th times 2 to the 2nd. 2 to the 5th is technically 2 times 2 times 2 times 2. 5 2's. 2 to the 2nd is 2 times 2. How many 2's do I have? Well, I have 7 of them. 2 to the 7th. So, same works over here. All we're doing is you're adding your exponents. Okay? Over here we have 1 and 4, so you keep the same base, add your exponents. Keep the same base, add your exponents. Keep the same base, add your exponents. We only do this when you're multiplying same bases. So it says complete this equation. 2 to the m times 2 to the n is 2 to the m plus n. So same base, pardon me, add the exponents. Okay? And if you ever get stuck with that, just draw it out like you did what we did here. Okay, it'll help you see that a little better. Write each quotient as a single power of 2 by first writing the numerator and denominator in expanded forms and then canceling common factors. Use a calculator to check your answers. For part A, 2 to the 3rd over 2 to the 1st. 2 to the 3rd is 2 times 2 times 2. 2 to the 1st is 2. Now, what is 2 divided by 2? Well, it's 1. It cancels out. So because I have enough over top of one another, I can cancel them out. How many 2's do I have up top? 2 of them. 2 to the 2nd power. Now, the trick here is you can take your top exponent and subtract your bottom exponent from it. Okay, so this one's written like so. 2 to the 5th over 2 squared What's 5 over, like 5 minus 2? 2 to the third. 7 and 3, subtract it. 2 to the fourth. What's 2 to the sixth over 2 to the sixth? Well, 2 to the 0 power. This is a very strange one. Everyone seems to get this one wrong, over, like, for as long as I remember. Anything raised to 0 power is not 0. It's actually 1. Alright, now, cool another way to think about it is, anything over itself is 1. So if you see the same thing over the same thing, you can just divide it. It's like saying 5 divided by 5 is 1, so on and so forth. So, complete this equation. 2 to the m over 2 to the n is 2 to the m minus n. You can subtract them. So in words, dividing same bases, we subtract exponents. Okay? Important to note that you do top minus bottom. That is important. I guess it would help if you saw it, huh? Okay, cool. So, looking good. Now, sorry, I'm trying to take my jacket off. It's got school. Expand each power and simplify to a single power of 2. Now, if I have 2 to the third raised to the second power, okay, what we can do here is it's basically 2 times 2 times 2, and I have 2 of them. Alright? Well, you know, how many do I have there? I have 6 total. So how did I get 6 from these two numbers? Well, I multiply them. Alright, so the easier way here is I wouldn't want to write out 2 to the fourth 5 times. It's annoying beyond belief. So just multiply these. 2 to the 20th, 2 to the 12th. Okay? So complete the equation, 2 to the m raised to the n. So it's 2 to the m times n. So when it's a power raised to a power, we multiply the exponents. Okay? Looking good. Ladies and gentlemen, these three right here are your most important properties. Okay? Like, these are things I'm going to assume that you know. Now we're going to work with them. Okay? Right now you're not supposed to be an expert after like looking at it for 5 seconds. You did learn this in Algebra 1. This is stuff that I hopefully you recall. It shouldn't take us too long to kind of bring back. But you will need to know this, okay? I don't ask you guys to memorize much, but you need to know these properties so you know how to use them, all right? But there will not be a formula sheet on this stuff on the test. On the back, sorry, I'm getting a little tickle on my throat. There are 7 basic situations you encounter when working with exponents. I'm going to list them now as the properties of exponents. You need to memorize them. It really helps us to understand how you can come up with each of them. For each rule, I will show an example. Spend each time with these. If you understand how they work, you definitely remember how to do them much better. Despite what you think, they do make sense. So, let a and b be real numbers, and let m and n be integers. The product power, which is what we had over there, a to the m times a to the n is a to the m plus n. You add the exponent. The power of a power property, a to the m raised to the n is a to the m times n. Okay? ab, the quantity ab raised to the m power, is a to the m times b to the m. That means both the things inside there can be raised to the power of n. Negative exponent. This one's huge. And this is like a new one for all of us, and we're going to get better at it. When you have a negative exponent, we don't want it. It's kind of like having a square in the denominator. You don't want a square in the denominator. Well, there's an easy fix for this. To make it positive, you flip it. So for example, just over here real quick, if I have x to the negative 2 power, you flip it to the denominator, you get 1 over x squared. But if I had something like this, 1 over x to the negative 2 power, do you see how x is in the denominator with the negative exponent? To make it positive, you just flip it to the numerator. Those are your 2 examples. The quicker you get better at that, the easier life's going to be. Okay? Alright, 0 exponent property. Anything raised to 0 power is 1. Don't forget that one either. It's kind of big. Just simple enough. And if you ever struggle with that, just take your calculator and do any number in the entire spectrum of the number line raised to 0 power, you get 1. A to the m over a to the n, you can do top minus bottom, m minus n. And lastly, power of a quotient property, a over b raised to the m is a to the m over b to the m. Got it. Please note for any of the fraction ones that they say that b cannot equal 0 or a cannot be equal 0, simply because you can't divide by 0. So, evaluating numerical expressions. This is a fraction 1, so I know I'm going to use my quotient of powers property. Top minus bottom because they are the same base. So 7 to 6 minus 3 is 7 to the third. I want you to leave it as the number raised to the power. Okay? It's just easier to work with. Here's my 3 raised to negative 2 power. I want to make that positive, so you flip it. 1 over 3 squared. Good. Here I have a power raised to a power. So I take these two numbers and I multiply them. 2 to the third. When you get good at this, you're going to fly through these problems. Now let's apply here a little bit to some variables. Okay. Here, 4 can get multiplied into both terms. Okay, let me focus this real quick. So it goes to the top, it goes to the bottom. So negative 3 times 4 is negative 12. Down low I got y to the 8th. Now please note, the x to negative 12, only the x is negative. So I'm only going to flip the negative exponent downstairs. So 1 over x to the 12th, y to the 8th. I don't change the y to the 8th because it's already positive. But because this was negative 12 in my numerator, I need to send it to my denominator to make it positive. Over here, the cube goes to both the negative 3 and the a. So then negative 3 raised to the third power, this is just negative 3 times negative 3 times negative 3, is negative 27. And these are all the same bases, so I'm adding the exponents. 3 plus 9 is 12, minus 7 is 5. Now you're probably wondering, oh, there's a negative right there, but it's not in an exponent, so it's okay. I only want negative exponents, so I want to flip them. Okay, this is when they start to get a little bit more difficult. The whole entire top quantity is squared, so square everything first. Don't forget your rules of exponents. Please excuse my dear Aunt Sally. Parentheses, exponents, so on. So the c to the 4th d squared, I get c to the 4th squared, d squared, over c to the 9th d squared. Okay. C to the 4th squared is c to the 8th, d squared over c to the 9th, d squared. These cancel out. Now, if I do 8 minus 9, I get negative 1. But I don't want negative exponents, right? So it's just 1 over c to the first power. You don't really put down the first power a lot of times. You just kind of leave it be. You should be in good shape there. Alright, last one for these notes. The radius of a basketball is about 5.7 times greater than the radius of a golf ball. How many times great as the golf ball's volume is the basketball's volume? So the volume is 4/3 pi r cubed. So we're plugging in, pardon me, a 5.7 in for our radius. Okay. So what we're looking to do here is we're looking to cube that. Okay. Which, give me 1 second here to grab my calculator. Alright, we're doing your 5.7 cubed. So 4/3 pi, 185.193 r cubed. So as far as how much bigger is it, how many times as great as the golf ball's volume. If it's 5.7 times greater, then that means that the volume is 1.85 times bigger. And that wraps it up. Sorry. The door just shut over there and it freaked me out a little bit during the morning. Alright guys, you may try out your homework, give it a go. And as always, keep up the good work and good luck. We're all counting on you.